Hello everyone. So today what we are going to discuss is about the fire and its chemistry, fire triangle, fire tetrahedron, different classes of fire as per ISO and NFPA. I've already covered fixed firefighting system as CO2, DCP, sprinkler system, hypermist, all its regulations, safeties on CO2 system, portable DCP, all those things I've already covered. If you have not watched, please do watch those videos. So without any further ado, let's begin the today's discussion, and that is about fire. So first of all, we look at the definitions. I've collated it from different trustworthy websites, reputed ones. So fire is a rapid oxidation of material, the fuel in exothermic chemicals. So there are two types of reaction, as you all know, that is exothermic and endothermic reaction. Okay, when the heat is released, that is exothermic chemical process of combustion, releasing heat, light and various reaction products. If you go on another definition, fire is a visible effect of a process of combustion, a special type of chemical reaction. It occurs between oxygen in the air and some sort of fuel. The products from the chemical reaction are completely different from the starting material. So when the fire is completely burned, we may have some residue, that is ashes. We may have carbon dioxide, carbon monoxide, carbon itself, water as well, heat as well, light as well. So these are different products. The flame is the visible portion of the fire. So what we can see is the flame is the visible portion. Flame consists primarily of carbon dioxide, water vapor, oxygen and nitrogen. So these are the components of flame. If hot if hot enough, the gases may become ionized to produce plasma. So if it is too much hot, the gases may become ionized to become plasma, depending on the substance, light and any impurities outside. The color of the flame and the fire's intensity will be different. So it depends on the intensity of the fire. So if it is more the intensity is much more, then it will form plasma. Now when we talk about combustion, so what is known as combustion? Combustion or burning is a high temperature exothermic redox chemical reaction. So these are this endothermic and exothermic, and both the reactions are type of redox reaction. Okay, you must have studied in chemistry, between a fuel and an oxidant, usually atmospheric oxygen, that produces oxidized, often gaseous products in a mixture termed as smoke. Okay, so these were the definitions of fire. Now, oxygen, fuel and heat are needed for fire to occur. This is known as fire triangle. So there are three elements that is needed. So what is known as is the heat, that's oxygen, that is fuel. So all these three elements are needed for a fire to occur. So these are primarily the primary. So from here you can have wood, which can act as a fuel. Now the fuel must be heated to its temperature for combustion to occur. So the fuel must be heated for at a particular temperature for the combustion to occur. The reaction will keep going as long as there is enough heat. So as long as the heat is present, fuel is present and oxygen is present, the reaction will keep on going, and this is known what is known as the fire triangle. Okay, but fire triangle itself is not sufficient to define a fire. So we came across a concept of that is known as a fire tetrahedron, and where we have this chain reaction. So all these three elements combine, but what continue, what substantiate, what keep the fire to go on, and that is known as chain reaction. So combustion is when fuel reacts with oxygen to release heat energy. Combustion can be slow or fast depending on the amount of oxygen available. Combustion, the result in a flame, is very fast and is called burning. So what is burning? Is a combustion that results in a flame, means very fast combustion where abundant oxygen is known as, that is known as burning. Combustion can only occur between gases. So combustion can only occur between, it is not the material that burns, it is the vapor that the material leaves. Wood doesn't burn, the vapor that comes out of the wood, that burns. Okay, remember this. Chemical reaction in the combustion process. So fuel can be solid, liquid or gases. During the chemical reaction that produces fire, fuel is heated to such an extent that is releases gases from its surface. So it releases gases from its surface. Only gases can react in combustion. Gases are made up of molecules, group of atom, When these gases are hot enough, the molecules in the gases break apart and fragments of molecule rejoin with oxygen from the air to make new products molecule. Water molecule, that is H2O, and then carbon dioxide molecule, that is CO2, and other products of burning is not incomplete. So how basically the fire occurs? So you see, when fire is held to a paper, now this is a piece of paper, the fire is held, molecules that are bound closely to one another on the surface of the paper are loosened. So those molecules which are there on the surface, those get loosened by the heat. They move further apart from one another, becoming a gas. So and they, what happens, see the difference between a solid, liquid and gases. So molecules are very closely packed in a solid, so what happens, it becomes loose, so it becomes much loose, so then it forms what is known as a vapor. The gases molecule combine with oxygen molecule in the air and the paper begins to burn. Okay, so this is the process of burning, how a fire occurs. Now there are two concepts of complete combustion and incomplete combustion. So you must have seen your stove burners gas in your home, that you see here is blue, but you see a jungle fire that is yellow or reddish in color. So why this is known as? So in complete combustion, the burning fuel will produce only water and carbon dioxide. So here the gases that we use, why we say the CNG, LNG, all these are to be non-pollutant, because only water and carbon dioxide, those are being produced, no smoke or other products. So there is no smoke or other. The flame is typically blue. For this to happen, there needs to be enough oxygen to combine completely with the fuel gas. Okay, so that is known as your complete combustion. Now you see here, this is incomplete combustion. Why? The reason being is that I'll tell you. Incomplete combustion produces products such as carbon. So here you see carbon, the ashes that remains, that is known as carbon, and carbon monoxide, that is CO, that is incomplete combustion in the absence of little lesser oxygen, that is known as carbon monoxide, the combustion that is taking, as well as water and carbon dioxide, as well as we have water and carbon dioxide. So three things are formed here, that is carbon, carbon monoxide, carbon dioxide, and we have water. The burning flame is typically yellow or orange and there is smoke. If there is not enough oxygen available during a chemical reaction, incomplete combustion occurs, and products such as carbon, carbon monoxide, as well as water and carbon dioxide are produced. Less heat energy is released during the incomplete combustion than complete combustion. Okay, less heat energy is released during incomplete combustion than complete combustion. In incomplete combustion, the burning flame is typically yellow or orange and there is smoke. Okay, now we go to our main topic that may be asked by the surveyor, that is known as classification of fire. So this was important for me to give you a background of fire triangle, fire tetrahedron, what is a fire, what is combustion, what is burning, what is flame. Okay, what is complete combustion, what is incomplete combustion. Now we come to the classification of fire. So there are two bodies. First of all is we are going to discuss about National Fire Protection Association. This is very important. Based on this only the questions are asked generally. That is NFPA in short form. So they categorize the fire, the classes of fire. It is done on the basis of combustible material that can possibly catch fire. Accordingly, the safeguards against the different types of fires can be planned. Now, when we talk about class A fire, you see here in the diagram, class A fire, that is, those are solid materials like paper, wood, clothes, plastics, all these things comes under class A fire. They are green in triangle, so you always find a white A background is the green. So this denotes this class of fire wherever you find it goes. So this is also important. What is the color coding for class A fire? Involves ordinary combustible material like paper, wood, fabric, rubber. Most of the times this type of fire is effectively quenched by water or insulating by other suitable chemical agents. So generally class A extinguisher that you find, those only have water. Okay, now when we talk about class B fire, then class B fire designates symbol as red square. So you have red square, that is triangle. Symbol is triangle, green in color. Now here it is square, that is box. Okay, red. Most involve flammable liquid like gasoline, oil, grease, tars, paints. Okay, flammable liquid and flammable gases. So dry chemical and the carbon dioxide are typically used to extinguish this fire. Okay, so water extinguisher, that is dry chemical, and carbon dioxide, CO2, are used to extinguish the liquid fire, that is oil fire, you can say, on ships. Okay, now when we talk about C, There is a symbol as a blue circle. So now here we have circle. Involves live electrical like motors, generators and other appliances. For safety reasons, non-conducting extinguishing agents such as the dry chemicals or carbon dioxide are usually used to put on these fires. So carbon dioxide are also used on electrical fire. We are also using, so this is one difference. In ISO you will find this class C fire is for something else, which we're going to see later on. But here in NFPA, class C is specifically for electrical fire. Basically electrical fire, whenever happens, it turns into be a class A fire, okay, or a class maybe B fire in some cases. Why? The reason being is that it catches fire because of short circuit, but there are electrical equipments which are solid, only wood maybe, or there may be some other appliances which may be fiber and other stuff. So this turns out to be a class B fire. So we can use here even DCP, dry chemical powder also, but we are not using, but because it leaves a residue which is very difficult to clean and it may damage the equipment. So that's why we are not using. We can use carbon dioxide as well as DCP. For safety reasons we are not using the DCP. Now class D fire. When we talk about class D fire, yellow decagon involve combustible metal. So here it is metal, magnesium, sodium, lithium, potassium, etc. Sodium carbonate, graphite, bicarbonate, sodium chloride and salt based chemical extinguishers these fires. So these are the fire combustible material: aluminum, magnesium, titanium, lithium, sodium, potassium. These are, this is the symbol, yellow in color, decagon we have. Now when we talk about class K fires, here you see class K fire. Now this is also different. Here in ISO you won't find, one is the C, one is the K. Okay, here in K, class K fires are fires in cooking appliances that involves combustible cooking media, vegetable, animal oils or fat. So these are a special type of extinguisher are being used. Okay, so you see here its symbol, it is directly K is written. Okay, because in kitchen we have kitchen fats, basically in galley we are using this type of fire, combustible animal or vegetable fat, because we are the oils we are using in the kitchen are of different grades and different variety, cooking oils in commercial cooking equipment. So this is the class K fire. Now you see here the symbol, when we talk about class A fire, water is the only medium. Okay, we are not using liquid on electric fire because that will cause a short circuit. Now when we talk about class B foam type can be used on class A fire, class B fire, okay, but others we are not using because here also we have water that is being present. So flammable liquid, I've already covered the foam type extinguishers, foam systems regulations and all in previous videos. Not suited to domestic use, it is not suited for the domestic use. Now when we talk about dry powder is applicable on all fire, okay, even on electrical equipment. But why I said that we avoid using, we use here only CO2, the reason being is that it will cause the equipment to not be in use. Okay, deep fat fire, or except K we can use DCP on all the classes of fire. Okay, now when we talk about CO2, we cannot be using on combustible material, we can use on gases, we can be using it on electrical fire, okay, but not on K. For K class we have separate thing altogether. So wet chemical we can use water as well as we can use this. Okay, now this can be used safely up to 1000 volt. Now this safe on both high and low voltage. CO2 is safe on both high and low voltage, but on high voltage we cannot be using this because that itself will react. Okay, use on extremely high temperature. So wet chemical is being used on extremely high temperature because the deep fat fires they are using extremely high temperature. Now you see color coding, I have already told. Wet chemical, that is yellow, vaporizing liquid, that is green, CO2 carbonate, that is black, foam, that is slightly pink, you are saying here, dry powder you see here blue, water that you find it here to be red. Now you see here. Now when we talk about ISO, that is ISO is International Organization for Standardization. Okay, now when we talk about classification as per ISO, class A is fire of solid material, that is common usually for an organic nature in which combustion normally takes place with the formation of glowing embers. Now you see class B fire was liquid or liquefiable solid. So which are liquid or liquefiable solid. Okay, so that will come in class B fire. Now when we talk about class C fire, fire involving gases. Now this class C in as per NFPO was involved in class B only. Okay, here you have a C has a separate category, and there C was for electrical fire. Here is C for gaseous fires. Now class D is fire involved in metals. Okay, so there also we had this metal. Now here you find it to be class F. There you had class K for fire involving cooking media, vegetables or animal fats in cooking appliances. So there are two basic difference between NFPA classification and ISO classification. In ISO classification, class C fire designates to gases. In in NFPA, gaseous fires are included in class B only, and class C designates to what is known as is electrical fire. And there we have class K for galley or cooking media oils, and there here we have class F for cooking media for galley oil. So I've already covered all those things. So what are extinguishers that are supposed to be used? So today we have covered what is a fire and what is a fire triangle, what is a fire tetrahedron, what is combustion, what is complete combustion, what is incomplete combustion, what is burning, what is flame. And then we went on to classification of fire as per NFPA, what is NFPA, and as per ISO, what are the difference between NFPA and ISO. And then we saw what are the different symbols used for fire and color coding. And then we saw what are the extinguishing agent that can be used on different grades of fire. Thank you so much.